How close are we with that? You're done? Back there? Cool. All right. All right. Couple things to note. We would usually actually not be told. They would most likely write it something like this. They would say, given these roots, find a polynomial. Find a polynomial with these given roots. So you would have to know without being told that negative root 3 is also a root, correct? When does that happen? When are conjugates absolutely also roots? In two cases. If we have what type of roots? Good. Yep, so irrationals, which you're saying radicals, you're right, irrationals, and imaginary solutions. Okay, good. So when you work backwards, you had an x minus 2, agreed? Then you had an x minus root 3. Then you had an x plus root 3. Do we all agree? So now from here, I saw someone last hour go about this the way hard way. What they did was they distributed these two together, combined like terms, and then distributed it in here. Yikes. Good point. You're saying we should do what? Yeah, do the conjugates, because don't conjugates have things cancel out middle terms? Okay, when you multiply that out, what'd you get? X squared, then what? Not the whole, like I don't care about the work because I'm confident. Minus 3, what? Okay, cool. You're right. Then from here we have an x minus 2, so when you distribute it, you got x. Awesome. Okay, good. That would be a shameful one to miss on an ACT, right? Okay. Next one is let's practice going backwards. The hardest thing I think for students sometimes is actually going backwards. It's always easier to draw in a graph than to work backwards and then write the equation. This is more likely though what you would see on an ACT, and then I'm going to throw a couple on the exam like this. Also, there's a bonus test review already available. No, next time is not the review. We're still a while out from that. I'm just giving you the bonus test review a couple times early for kicks and giggles. It's over there. You can get it in a second. It's similar to this. It's going to be doing this, so everybody try it. Write the equation to the following. Here is a tangent equation. Here's a tangent equation. Things have changed though. Amplitudes changed and possibly period. Now, what is the period for regular old tangent? Pi, right? Tangent has a period of pi. So how we find the period is technically pi over b. So now b is what goes in the front of x. So we need to figure out what that is. What does b mean? Number of cycles from 0 to pi for tangent, right? And then also you could work backwards. Think about this. If you know the period, which means length of one cycle, then you could plug it in right there and then solve for b. So use that, see if you can come up with the equation, and then let me know what you get. And you can talk to each other, but this is going to be tested on, so we need to be able to do it. Okay, the first thing I would do is I would draw in where my asymptotes are at. So on this first graph here, to me it looks like my asymptote is here and here. Agreed? Well then guys, then also it looks like it's here. Okay, well then we know our period. If you know where the asymptotes are, you know what the period is, because period means length of a cycle. From here to here is pi halves length. Agreed. So then from there, if you know the period, you know b, because plug it in. You have pi halves equals pi over b, and then solve for b. So we cross multiply, so that's b pi equals 2 pi, so then b equals 2, because you would divide out your pi's. So then you can go put in a 2. B is always in front of x, and then you would say my amplitude, my 0 is always at the exact halfway point between the asymptotes, and then to find the amplitude, you'd go to the 0 and the asymptote and go halfway, and then see how high up you're at. 2. Does everyone see? So it was 2. Most of you got that one right. Very good. All right, over here, this one was maybe a little bit, for last hour, it was a little bit harder for them to decide where the asymptote is. What would you think? You're thinking pi, I'm hearing? Okay, no, even though we can't see over here, where do we know it would be? Because of how tangent's graph works. Good, negative pi. Oh, I didn't draw that to scale very well. So you're saying it's also here at 3 pi. All right, well then you know period. What's the distance from there to there? 2 pi, isn't it? Pi to 3 pi is 2 pi in length. So now you'd say, I know my period is 2 pi, so you'd say 2 pi equals pi over b, and then solve for b, cross multiply. So So 2 pi b equals pi, so then divide by 2 pi. So b is a half, everyone. So then you'd go put in a half right there, and then your amplitude, you'd go halfway between the 0 and the asymptote, which is right there, and go as high up as you go. Oops. Halfway between 0 and here is here, and it's up at 4. So guys, don't make it harder than it needs to be. That was not bad, right? Okay, awesome. Okay, let's get started on today's lesson 6-8. It's just actually a right triangle trig application. So it's kind of interesting. We should have just put it on the last test. Honestly, though, I'm not mad it's on this test because it kind of gives a little lee room because the other stuff's a little bit harder. So we already know how to solve right triangles by right triangle trig and Pythagorean theorem for sides. So when it says solve the triangle, what you're going to do is find all missing angles, all missing sides. So what I would want you to do is make a bucket of solutions, I call it. Now, this is angle B. Do you agree? So we need to find angle B. Then also we need to find, if this is angle C, the side directly across from it would be considered side C. If this is angle A, the side straight across from it would be side A, everyone. So then from there, all we have to do is set up some true statements and solve. So angle B is going to be really easy because we'll do 180 minus 34.2 minus 90. You guys see what I'm doing? Yeah. All three angles of a triangle add up to 180. Okay. 50. Yeah, you can just put it on the triangle. Okay, let's move on to side A or side C. It doesn't matter. I'm going to do side A. So I'm going to call this angle theta. Opposite and adjacent. So a true trig statement would be tangent, since we were given opposite and adjacent. So tangent of theta is equal to opposite over adjacent. Plug in what you know. So tangent of 34.2 is equal to my opposite side's A, my adjacent is 19.4, and then it's just algebra to get A alone. So we times up by 19.4, and then we would just type it into our calculator, making sure it's in degree mode since we're inputting a degree. What would the side length be for side A, please? Everyone help me out with a quicker. Perfect. And so this is a general rule of thumb. If the original has one decimal place, we'll go with that. And then side C can be found by setting up another trig ratio, or now can't I do Pythagorean theorem? So you do 13.2 squared plus 19.4 squared equals C squared, and what do I get for C? And then we make sure we square root it. What is it, sorry? So 23.5. Okay, pretty easy. We've now found all the missing angles and all the missing sides. Yeah. There is going to be one thing that we just learned that's kind of interesting in just a second, though. So a safety regulation states the max angle of an elevation for a ladder is 72 degrees. A fire department's longest ladder is 110 feet. What is the maximum safety rescue height that they will be able to use? So I would just draw a picture. So we have a building. And then if you think about it, a ladder would lean up against a building, something like this, right? Angle of elevation. So there's our right triangle. Where would the angle of elevation be? Yep, good. Right here. And that is 72 degrees is allowed. Now, there are these like type of safety regulations in real life to help make sure that they don't have any problems. Like if we were to scoot this ladder closer and it would be higher up, now it's not 72 degrees and it's no longer safe because it could tip or whatever. So these kind of things exist in real life. Anyways, going on. And then it says the ladder is 110 feet. So in this one, this part right here is 110 feet. Agreed? Yeah. Now it says, what is the max height? So we want to know the building height. So now you would set up a true trig ratio. Here's theta, opposite, hypotenuse, so it must be sine. Sine of 72 is equal to opposite over hypotenuse. The math on this one's turning out easy again. So then you would just type it in. How high of the building can it be? If this was truly the dimensions. Okay, perfect. Awesome. Just set up a true trig ratio. All right. Right. Okay, so now right here, let's look at this one. There's a couple of different ways to solve this one. A lot of times there's going to be multiple right triangles within one problem. So you'll just kind of draw out your picture. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees. Smokestack just means like a little part of the building where smoke comes out of it. So here I have a building, here's my smokestack, and it said the angle of elevation to the top of the building, or bottom of the smokestack, is 35 degrees. From here to here is 35. Everybody see? Then it says, and the angle of elevation to the top of the smokestack is 53 degrees. So from here to here, so that'd be to the top of the smokestack is 53 degrees. It just wants to know what is the height of the smokestack. What is the height of S? So guys, if you need to, split up your triangles. What do we have here? We have one right triangle right here, 90 degrees. This is 35. Isn't this 200? Yeah. And then we don't know what that is, so that's side A. Now we have another right triangle, a bigger right triangle, and then our angle is 53 right here. And then isn't this side length A plus S? Okay, and then right here is 200 as well. So now right here we can solve for A. Once we know A, then we can go through and solve for S. And there's a couple different ways to do this one. Somebody else last hour just called this X. They found this entire side length, and then they ended up subtracting them. That was actually probably easier. You guys see what I'm saying? Okay, so let's find this side. Set up a true trig ratio, opposite, adjacent. So tangent of 35 is equal to my opposite over my adjacent. So then we have 200, tangent of 35 equals A. So what's the side length of A? 140.0 then. Okay. All right, so then we know now this is right here 140, so we can plug this in. We can do this two different ways. Would you rather plug it into this part, or would you rather just solve for X and then subtract it off? Okay, solving for X then, we're going to be opposite, adjacent. So now we're doing tangent of 53 is equal to my opposite, which is X. My adjacent's 200. So then 200 tangent of 53, 265.4. So that would be this entire length, 265.4, and then we would subtract off 140. Nope. Yes. My bad. Right here is 140. So we would subtract off 140 to get this. This is what we want. What is it? 125.4 is the height of the smokestack. Does that make sense? Okay. So the right triangle, the story problems are going to be pretty straightforward. Let's read this one. A pool that is 20 meters long. So right here, think about jumping in a pool. This actually picture makes quite sense because you're going to be swimming along and it's going to get deeper. All right, so it says a pool that is 20 meters long has a shallow end of 1.3 meters. To the deep end, it is 4 meters. What is the angle of depression to the deep end of the pool? Now, angle of depression, you guys, let's think about it. If I had a right triangle sitting like this, we're not going to call, a lot of you accidentally called this angle of depression, which was incorrect on the test. And I remember I brought that up and I said at least 30% of you are going to do that at least. You did. Okay. Not to say I told you so, but okay. So just a reminder, angle of depression is not this angle. Angle of depression is the same as angle of elevation. So if we look at this picture here, where should I draw my 90-degree angle? Right here and right here, correct? Now looking at this big, huge one, it's technically not a right triangle because we have this piece here. So we've got to go down and look at just this right triangle right here. We can only use this. So now if we think about it, it wants to know what our angle of elevation is, because that's the same thing as angle of depression. Wouldn't that be down here by the 90 degrees? This is angle of elevation and depression, they're the same thing. So now from here, we're going to have to set up a true statement. What is the length from here to here? 20. What would be the length from here to here? Yep. Because this entire thing is 4 meters, and then the shallow one is 1.3. So to get down here on the actual triangle, we put 2.7. So now from here, you'd set up a trig ratio, opposite, adjacent. So you'd say tangent of angle theta is equal to my opposite over my adjacent. Then from there, you'd say I'm solving for theta. To undo tangent, I would take the inverse tangent. Whenever we're finding an angle, that's the only time we take an inverse. So we have theta is equal to, and on the ACT, they'd leave it like this, tangent inverse of 2.7 over 20. They would leave it. But I want you to tell me, what is the angle it's going to the deep end at? Perfect, 7.7 degrees, which seems reasonable because it's going to, in real life, this picture isn't very accurate because a pool usually grows a little bit slower to the deep end. So 7.7 degrees makes pretty good sense. All right, let's write this down. This is going to be really different, okay? Even for me, it was different. This was what I had just never used. I personally don't, like, I'm not a sailor. People that are sailors, you actually talk like this for direction. They talk about degree measures to get into a certain direction. To get to a place, they use north, south, east, and west, and then degree measures. So we'll talk about how it works. And then also they use it in airplanes. Yeah. So we have to be able to read trig bearings, and we usually go clockwise from the north. So let's look at what this would mean. So let's look at drawing an angle of, let's start here. North 80 degrees west. That would mean, okay, look, here's, I need to be able to write. There we go. So north 80 degrees west would be what direction? So let's start here. Here is the starting point. Here's north. And then we're turning and going 80 degrees in the westward direction. Do you guys see? So wouldn't that be like over here kind of? This full thing's 90. So now we're turning in right here would be my angle up here, 80 degrees. And then that would put us in the correct direction. That would be putting us over this way. Does that make sense? Okay. Now look, notice that this angle 80 is not going to be in a right triangle. We are going to still just be dealing with right triangles. So what could I do? Couldn't I drop straight down and make a right triangle right here? Well, this would be what? 10 degrees, and then do you see how you could maybe use that? Okay, cool. Let's draw this one. North, 45 degrees east. So starting here, you're looking north, and then you're turning and going 45 degrees eastward direction. So now you'd be going from here to here. That's just how they say it. So that's steering the boat in the correct direction. So this would be 45 degrees, and then we're going to be not using this up here probably because this is not a right triangle. We would drop straight down, call this 90. So then wouldn't this be 45 degrees? So it's still just going to be a right triangle trig. The hard part is just drawing a correct picture. Now this one is saying starting southward and then going 35 degrees in the westward direction. So that usually doesn't happen. They usually do north, but it's not a big deal if it does. So that would just be this angle, 35 degrees. And then we would drop straight down, create a 90 degree, and we could continue from that. All right, so it's just being able to draw these in correctly. Now, you make sure if you are doing trig bearings, I always draw in this north, south, east, and west to help me draw it correctly. So look at this one example, and we only have one more example, and then we'll be done. Okay, so it says a ship leaves port at noon and heads due west 20 knots. Now, 20 knots just means 20 nautical miles per hour. Nautical means on the ocean. So literally, they're just saying the ship's going 20 miles per hour, but it's just on the ocean, not on the street, if that makes sense. So that's what a knot is. Then it says at 2 p.m., the ship changes course north 54 degrees west. Find the ship's bearings and the distance from the port of departure at 3 p.m. The hardest part, you guys, is drawing the correct picture. So watch very carefully and let's think through this. All right, so I like to have a little north, south, east, and west thing to refer to if I need to. Never eat soggy waffles, however you remember it. All right, so let's draw a really as accurate picture as we can. Right here is 12 o'clock noon, agreed? We're starting. That's my starting point, and it's heading due west. So now the first thing it's doing is heading west this way, agreed? Now it says at 2 p.m., then the ship changes course. So now I'm going to put a stopping point because it's technically stopping and changing course. Anytime I change course, I draw in a new, you're going to see me draw in a new north, south, east, and west thing. Here's north, south, east, west. You guys see what I'm doing? North, east, south, west. Anytime I change directions, I personally draw this in. Okay, so now at this point, what they're doing is they're going to turn north, starting eyeballs in the north. They're going to turn 54 degrees to the west. So that would be over here, wouldn't it? And head in that direction. So this angle from here to here is 54 degrees. Then they are going for an amount of time, and they stop at 3 o'clock. Oh, and this was 2 o'clock. I should have wrote that. in more information here. What was the distance from the starting point to this point? 40 miles, correct? Weren't they going 20 miles per 1 hour? 2 hours have passed. So in this distance, they've gone 40 miles on the ocean. Now from 2 o'clock to 3 o'clock, they've gone for an hour, so this would be 20 miles. And then what they want to know is, now, what is the distance from this stopping point to the starting point? Now the shortest distance would be drawing straight through like this. But notice this is not a right triangle. Look at it, it's obtuse, right? We have actually not learned how to solve any obtuse triangles yet. We will learn later in this unit, but not right now. So what we're going to have to do is we're going to have to create right triangles and use those. So it says, find the ship's bearings. I like to do that second. And the distance from the port of departure at 3 p.m. So we need to find this side right here. Now, what do we see here? A couple right triangles. Now, usually the best thing to do is to take this and drop straight down and create a 90-degree triangle. You guys see? We have a 90-degree triangle. Now, technically, we have two 90-degree triangles. Don't we have this big 90-degree triangle right here? Which is what we're essentially going to want, so I kind of redraw them. I have my big 90-degree triangle. What do I know? That this is question mark. Do I know anything else? From here to here is 40, but I don't know this length, do I? So we could call that x and y. So isn't this 40 plus x? And then we have a y. We have no idea anything else. So that, we don't even know enough to begin. Well, what other right triangle do I see?
There's one inside of the
right here? Yeah. That's a small right triangle right there. I'm going to use that. So there's a 90. This is y. This is x. What would this angle right there be? Yep. Yep, 36 degrees. So now we have a right triangle. We know this is 36 degrees right there. And now this is, from here to here is a length of 20. So now do you guys see how we can solve for y and x? And then we'll just plug it in, and then we'll be able to do Pythagorean theorem. Okay, so set up a true trig ratio. Opposite hypotenuse. So sine of 36 is equal to opposite over hypotenuse. So 20, type it in, sine of 36. Yeah, make sure your calculator's in degree mode. Okay, let's go with 11.8 then. So now I can go put right here 11.8. Great, great. Now from here I could do Pythagorean theorem or set up another trig ratio. So you could do 20 squared minus 11.8 squared and then square root it, and you would get 56.1. No, you would not. You would get 16.1. So now right here, we have a 16.1, so this entire distance is 56.1. Now how would I find question mark? Pythagorean theorem. 56.1 squared plus 11.8 squared is equal to question mark squared. And then you would do that, and then you'd square root it, and you would get 57.3. So that's how many miles if they were to go the shortest distance back. So they would say 57.3 knots, because that means just miles on the ocean. There's our first answer. Now the hardest part, I think, for people is the next part, which is find the bearings. If we were going to start here and go straight here, instead of having to go over and up, what would be the bearings to get from point A to point B? So what I would do is, it wants to know, starting from the port of departure to the place you want to go. So I go back to the departure point, and I draw in my north, south, east, west. Do you guys see what I'm saying? Because how do bearings work? We always go north and then head eastward. So, or we can go north and then westward, sorry. So I'm starting north, starting here. Then wouldn't we be needing to find this angle? Because then we could say north, whatever degrees, heading west. Yes. So we need to find that angle right there. Any suggestions? To find that angle right there?
Yeah.
But then wouldn't that only be this angle? But that was a good thought. What angle could we find on this bad boy? That one. Couldn't we find this one? And then if we know that one, don't we know that one? Okay, so let's set up a trig ratio. Opposite and adjacent, sure. So that'd be tangent, so we'd say tangent of angle theta is equal to my opposite, 11.8, over adjacent, which was 56.1. So then we would do tangent inverse, and that angle is 11.8 degrees. Right here is 11.8 degrees. 11.8. Well now, if we know this angle is 11.8, this angle must be 78.2. Agreed? So now what you would say is, they're going to head 57.3 knots at north, 78.2 degrees in the westward direction. And that would put them in that spot, in the correct spot. There you go. Okay, now interesting fact for you. What's so interesting about this is for ships, they always start north usually, but then they can go east or west as you just saw. But for airplanes, not true. Airplanes always go off the north and no matter what, head eastward. This is always what they do. So if I wanted to get to this point, let's just say like over here, this point, from here to here. To describe it, we would say, okay, starting north, we would have to go clear to here, from here eastward, so it's going to be some angle over there. Does that make sense? So like 230, for example, 230 degrees. So they just actually state the degrees without any further explanation. You just have to know it's starting north and then heading eastward. Okay, so let's read this. A jet leaves Reno, Nevada, and is headed towards Miami, Florida at a bearing of 100 degrees. So with planes, I always draw this little plane to kind of work off of, and then my starting point is always at the origin. Okay, so my starting point is Reno, and then we're going to 100 degrees, it says, to Miami. So think about this, starting north, 100 degrees would be somewhere over here, agreed? From here to here is 100 degrees, and then they're going to stop at, what was the other place? Alright, so now it says, how far north and how far west is Reno relative to Miami? Oh yeah, and sorry, I didn't read the next part. The distance between the two cities is approximately 2,472 miles. So 2,472 miles. Alright, now if you will notice something here, isn't it true that I can drop straight down, create a 90-degree angle? Well then, what's this angle inside? 10 degrees. So I need to draw this a little bit bigger for my own personal part. 10 degrees, and then we knew this was 2472. Now don't we just need to know this and this? Isn't that going to be north and west? Okay, so go ahead and solve. So opposite, hypotenuse, that's sine. So sine of 10 is equal to x over 2472. So calculate it. You'll times up by 2472. Thank you. 429.3. Right here is 429.3, and that would be heading north. Agreed? All right. And then, because we're answering part A. And then how far west? So now we just solve for y. I did Pythagorean theorem, and I got 2,000. No. Yep. What did I get? Maybe I didn't write it down. No, I did. 2,434. So I did this squared minus this squared equals this squared. So you get 2,434 miles. So that would be west. Is everybody okay? Okay, then it says, if the jet is to return directly to Reno from Miami, that's backwards, it's from Miami to Reno. We already did the Reno to Miami. Now it says going backwards. If we were to go to Miami and head completely back to Reno, what degree measure would we have to tell the plane to get headed in the correct direction? So what I would do is, once again, I'm going to go to the starting point and draw in my little perfect north, south, east, and west thing. And then aren't we starting always off the north and heading east And so we've got to go back to this line, right? So, almost, it's 280. Right, so we add up 90 plus 90 plus 90 plus 10. Now, why is this 10 if this is 10? Alternate interior angles. So this is also 10 degrees, so that would be 200. You would literally just say 280 degrees. That's all you have to say for planes. Because they'll know it's starting north and heading eastward. Okay, give it a try. The rest of the time is yours to do homework. The hardest part is drawing the picture. You need to practice.